Hi, I'm going to be going over some notes on covalent bonds today. Covalent bonds are similar to things like carbon dioxide, and we're going to talk about how these bonds work and how we draw them. This example here is the Bohr models, but we are going to use Lewis dot structure when we bond for covalent bonds today. All right, so covalent bonds are bonds between atoms that share electrons. The type of covalent bond depends on the difference in electronegativity, and we'll talk about what that means in just a moment. There are two main types of covalent bonds. There's polar covalent and nonpolar covalent. Now, for this class, you do not need to know the difference between polar and nonpolar covalent, but if you take upper level chemistry at the college level, you'll have to understand the difference. And so we're going to go over them just very briefly. For our class, we're going to learn covalent and ionic bonds, and you just have to be able to tell the difference between those two types of bonds. All covalent bonds are generally between two nonmetals, and that's what makes them different than ionic bonds. And sometimes metalloids are involved, but it's typically just two nonmetals. Remember, nonmetals are the ones on the right side of that stair step from that bonding inquiry activity that we did earlier this week. Okay, so the two types of covalent bonds, just to overview, polar covalent is when the shared electrons are not evenly shared. They spend more time on one of the atoms than the other. It causes an uneven share, and this happens when the electronegativity is between 0.5 and 1.7. Nonpolar covalent is when electrons are shared equally between the elements that are part of the bond, and this is where the electronegativity is greater than 0.5, and we'll look at electronegativity in just a second here. Okay, so this is the electronegativity chart. This tells the electronegativity for each element in the periodic table. We don't need to look at it to tell polar or nonpolar, but where this becomes useful is when we have bonding and we're writing the chemical formula. How do we know which element comes first and second in that formula? This is how we figure it out. And so there are some patterns to this chart. As we go from higher up in a group and we lower down through the group, you're going to notice that the electronegativity decreases as we go down, and it's going to increase as we go from left to right. You're going to see there are some elements that say Na. It just means that they do not have electronegativity. If you think about these three elements that have the Na and this one as well, they are all noble gases. Noble gases have a full valence shell, and they are not very likely to be bonding because they don't need electrons to fill their valence shell. All right, so we're going to talk about single bonds first. So there's a couple of examples. We have hydrogen here. Hydrogen has one valence electron. Now, in this Lewis dot, they drew it over on the right-hand side. In our examples, when we've done these before, we've typically put our Lewis dots up here on the top. Okay, it really doesn't matter so much. I'm not going to be picky if you put it on the wrong side. I'm not going to take points off on a test or a quiz, but you do need to put them in pairs. So, for example, if we have 4 electrons, they should go 1, 1, 1, 1, and then start doing the 2, 2, 2, 2, rather than, 1, 2, 3, 4 all on this side or something. Okay, we show the covalent bond as a line like it is here. Now, in this example, they have the dots for the electrons. You can also just write this H and H and just draw a line. You don't need to have the dots on the end. The line indicates we have 2 electrons that are being shared here. Okay, same thing with fluorine. One thing you do want to do is like what we have on fluorine. You can see here's those paired electrons on each side. The reason this is helpful is you want to go back and count and make sure we're filling the valence shell. So with hydrogen needs 2 valence electrons, and it gets 2 because they get to count both of these because they share. So this one has 2 and this one has 2. With fluorine, we've got 2, 4, 6, 7 valence electrons, and it needs 8, so it's looking for 1. So they're going to share. So now we have 2, 4, 6, 8, 2, 4, 6, 8. Always want to double check that you're filling that valence shell. If it's not full, then you probably didn't do the bonding correctly. All right, on this one, we're going to talk about double bonds. Now, there is something that is missing on this one. I am going to get a different color here. I wish this was a little bit thicker, but we have carbon, which carbon has 4 valence electrons from our periodic table. And it's just missing over here. So we have oxygen, oxygen, carbon, and we have double bonds that are happening. Okay, with this one, the reason that we do this part is just to help us think. So we know that this has 2, 4, 5, 6. So we know we need 2 more electrons to fill. This one needs 2 more electrons as well. And this one needs 4 electrons. So when we share, now this one has 2, 4, 6, 8. This one has 2, 4, 6, 8. And the carbon has 2, 4, 6, 8. And so those are all full. Again, you can also write this O, double bond, carbon, double bond, oxygen here. You could also put the dots on top and on bottom rather than on the side, and that would be fine. I just ask that if you have them in pairs, we don't want to. What you don't want is something where, you've got all 4 on one side, or you're kind of making a ring. You want to try to keep them in pairs. It just makes it a lot easier to count. This one, we have nitrogen. It has 5, so it needs 3 valence electrons. This nitrogen needs 3 valence electrons, so they do a triple bond to share 3. Okay, again, another way we could write this is you could do the 3 in the middle rather than doing a top, a middle, and a bottom. And then we could just put our 2, our other pair on the side. So 2, 4, 6, 8, 2, 4, 6, 8. All right. So there are 3 steps when we bond. And the first step is we're going to draw out the Lewis dot structure. Then we're going to use lines to show where the electrons are shared. And then the element with the lowest electronegativity number is written first. And that has to do with this part, that the molecular formula or the chemical formula for the compound. So this one we're going to do is H2O, or water. So we have H plus H plus O. And we're going to draw a valence electron. So hydrogen has 1, and this one has 6. Okay, now there are a couple ways I can draw this. I could do the hydrogen, oxygen, hydrogen, and then here's my other dots. So now I've got 2, 4, 6, 8 for my oxygen, 2 for my hydrogen, and 2 for my hydrogen. I could also draw it horizontal, so hydrogen, oxygen, hydrogen, and then I'd have 2 valence electrons on top and 2 on bottom. Either one of these is correct. You can draw them at angles, you can draw them straight across, you could even draw them vertically. It doesn't matter as long as you're representing all of the valence electrons and you're doing your bonding correctly. There isn't a right or wrong answer. We're not worrying about molecular shape right now. This H2O, we talked about lowest electronegativity, and so we know that we write this as H2O. The 2 indicates that we have 2 hydrogens. There's no number behind the O, which tells us we only have 1. If we go back and look at electronegativity, hydrogen is here at 2.20, oxygen is 3.44. This is the lower electronegativity, which is why we write the H before the O. All right. And we're going to do one more practice, and then you're going to do the rest on your own. So we have phosphorus, which is P. Whoop. And we have nitrogen, which is N. If I look at my periodic table, phosphorus has 5 valence electrons. And nitrogen has 5 valence electrons. So I'm adding these together. So I'm going to have P and N, and they both need 3, so they're going to do a triple bond. and we have 2 additional valence electrons. So 2, 4, 6, 8, 2, 4, 6, 8. And then we just look at that electronegativity chart again for P and N. N is up here, P is here. P has lower electronegativity, so if we were writing these as a symbol, we would write P and then the N. Okay, I want you to pause the video and try doing this one, and this one. And then when you unpause, I'll go through them with you. Okay, so nitrogen and nitrogen, we just did nitrogen over here. It has 5. I wish it was making my dots a little darker. So again, this is a triple bond. And this would be N2. All right. Chlorine has 7 valence electrons. And hydrogen has 1. So with this one, we have a single bond. And then our chlorine has 6 more, so 2, 4, 6, 8, and 2 for hydrogen. If we look at electronegativity, hydrogen goes before the chlorine, so it's HCl. Our next one, we have oxygen and sulfur. Oxygen has 6 valence electrons, and sulfur has 6 valence electrons. So they both need 2. They're going to do a double bond. So we have O and S, double bond. So this one has 4 valence electrons, 4 valence electrons that are not part of the bonds, 2, 4, 6, 8, 2, 4, 6, 8. They're full. If we go and look at electronegativity, this would be SO. All right. And then in summary, a covalent bond is between what types of elements? Non-metals. Covalent bond that has the highest difference in electronegativity is non-polar. Lowest difference is polar. Covalent bonds are formed by sharing of electrons. And Lewis dot diagrams of covalent bonds show the sharing of electrons with a line. All right. On Friday, we are going to do some card game practice with covalent bonding, and then next week we will do some more practice with this. So you'll get more opportunities to work on covalent bonding before we quiz. Please let me know if you have any questions. Thanks.